extended dynamic range Pro as well. It appears in a 75-inch, and that's replacing X91C and the X94C as well. Then we've got the XD9 III, our hero product for FY16. 65-inch and a 55-inch, replacing X90C and X93C as well. Again, extended dynamic range Pro, but this time with our slim backlight drive technology. And I'll explain that a little bit more in a second. Curve model, SD85, replacing the S85C from FY15. Again, 65-inch and a 55-inch, and it has that beautiful slim curved design. And then the XD85, replacing the hit model, which was the X85C from FY15, in a variety of different sizes as well. So we've got 85, 75, 65, and 55. Slim, crafted aluminium design. It looks fantastic. Referring back to the XD94 and the XD9 III, you will notice all of those TVs I just introduced are 4K HDR TVs. Now you might have questions around this later which we can answer, but we've chosen not to use the UHD Premium logo on our 4K TVs, 4K HDR TVs. We're going to use our own 4K HDR logo across a number of different categories to really simplify the great Sony 4K HDR ecosystem. So we'll see that logo appearing in lots of different products over the next couple of months and years. I would like to point out though, the XD94 and the XD9 III both meet the criteria that UHD Premium would set. So with reference to things like peak brightness, we've got over 1,000 nits of peak brightness in both models. We cover off over 90% of DCI-P3 colour space as well. So if we were to put those models forward for UHD Premium, they would meet the equivalent standards. But 4K HDR, what's it all about? Well, the basics here. High dynamic range, or HDR, it's a new video format which can deliver a much wider range of brightness and a wider range of colour as well. And basically, that means everything you watch, your movies, your TV shows that have been recorded in HDR will look more realistic, more true to life, much closer to how we actually see in real life as well. To explain a little bit further on here as well, I've just got this diagram. Now, I see some great cameras around here, and these days, a lot of the professional cameras used within the movie industry, within the sports industry, can actually capture a huge amount of brightness, contrast, and colour. But when we look to post-production and distribution, so Blu-ray discs, DVDs, streaming services, the old standards meant a lot of that information was essentially compressed away. So you lost a lot of that brightness and contrast, you lost a lot of that colour. So when you watched it back on your display at home, you didn't get the true sense of what was originally captured. With high dynamic range content, or HDR content, again, camera capturing all of this information, it looks fantastic. But thanks to those new standards that we're using, much more of that information is maintained. And then when you go and watch HDR content back on your HDR TV, you get to see all of that full colour, full brightness range in your picture. So overall, much, much better picture quality. To explain it in a little bit more depth, I've got this quite technical slide. I know some of you are quite techy, so this could be interesting. So we've got two lines on this graph here. Line number one is this paint line, which is the original signal, how something's being recorded in the first place. And then the blue line is the panel performance here as well. So you can see with standard dynamic range, with no picture enhancements, so say for example in Cinema Pro mode, the panel will match the performance of that original signal. If we start adding in picture enhancements, as we've done in the middle here, what you can see is there's your original line again, so I'll use my laser. What the panel will do is try and improve and expand that to upscale it essentially. And you can see some bright objects can be seen, even though we're ramping up the brightness, you don't get that full subtlety and nuance that you would from HDR. Now the big difference with HDR, as we can see over here, is the original signal has a lot more brightness information in it, a lot more colour information in there. And thanks to the panels that we use these days, they're able to show and convey all of that information in the picture to give us great picture quality. So as you can see, if you compare out the window on all of these, even very bright area, you still get that information, you still get that detail in there. And I know we mentioned brightness a lot when we talk about HDR, but that's not the full story. Colour plays an incredibly important part in the 4K HDR story as well. So here we have different kind of colour gamut ranges. So the yellow line, that yellow triangle here, that's called Rec 709 or BT709, which is the standard used on Blu-ray discs, etc. Been standard in the past. With 4K HDR, we've got this BT 2020 or Rec 2020. So with 4K HDR, you'll get a much wider range of colours being covered. Well, that's not the whole story. When we add in brightness as well, so if you imagine taking this and laying it and adding another axis into the equation, we're talking about colour volume. And when you add brightness in with all the different shades and tones, we're moving from this kind of volume all the way up to this kind of volume. So again, that's one of the reasons why 4K HDR content looks so incredible. I guess you're all wondering, well, where are we going to get this 4K HDR content from? At the moment, streaming services, Amazon Video have already launched 4K HDR. Netflix launching 4K HDR content very soon. Netflix is a big one there. Broadcast, BBC, NHK are doing a joint venture to set the standards for broadcast in HDR, and we've got a number of different companies testing HDR currently. And finally then, physical media, packaged media, 4K or Ultra HD Blu-ray, again, coming very soon. There's lots of movies coming out in HDR during FY16. And from ourselves, from Sony, we will launch an Ultra HD Blu-ray player by the end of FY16. So by the end of March 2017, we'll have a 4K Ultra HD Blu-ray player as well. So plenty of content to come. So the final bit then is just to tell you a little bit about slim backlight drive. We're probably familiar with these kind of different backlight systems or edge LED systems. So we've got conventional edge LED and we've got full array LED backlight. So what we've got on an edge LED, single LED module, light guide plate, LEDs go on, light comes out of the screen, LEDs go off, light stops coming out of the screen. Fairly simple and fairly straightforward. Limited local dimming though, great value, you get lovely thin TVs, which is fantastic. Full array LED backlight though, if we look at that, more expensive, but more accuracy in the local dimming side of things. The TV does tend to be thicker. So as you can see here, LEDs directly behind the LCD panel, LEDs turn on, LEDs turn off, and it allows you to get the light onto the screen more accurately to where you need it. So a fantastic solution and gives great picture quality. Slim backlight drive, however, is a very cool system. It's an edge LED system, but it gives you the effect of a full array LED backlight. And this is information that we normally don't share, so this is pretty awesome. It's unique Sony technology. Many people are taking photographs, good. So we've got two LED modules as opposed to a single LED module. We've got two light guide plates, and combining those two elements together, we can achieve light in different areas of the screen, so creating much more like a grid-type pattern on the screen, which again, very cool, and allows us to get light to where it's required on the screen very simply and very easily. Net result then is you get this kind of effect. So conventional local dimming TV, trying to light these balloons on the screen, you can often get quite a grey area around here while it's giving your LEDs on either side. With slim backlight drive, we're getting that light to exactly where we need it on the screen, giving great bright areas, but really nice deep dark black tones into the bargain. Fantastic. And again, we'll have a look at that in a few minutes. Final element then, very important, is upscaling. So for upscaling, for a long time we've been upscaling resolution. So using 4K extra reality powered by the X1 processor to give us near 4K quality for resolution. Triluminous display does a fantastic job of upscaling from a narrow colour gamut to a wide colour gamut. Now, with Extended Dynamic Range Pro, we're upscaling standard dynamic range to near high dynamic range as well. So you're getting your full upscaled image. Fantastic. Thank you very much for your time. Thank you for listening. And we'll have a closer look at the technology in the TVs in a few minutes when we break up into our groups. Thank you.